Hello, my name is Chalapot. Today we will show you how to solve the question about resultant forces and resultant moment. In this question, if you see the question 1 in the lecture 4, you will realize that it asks you to actually find the summation or resultant of forces and resultant moment about point O. It doesn't actually ask you to do with any specific method. So we'll show you in this one, we're going to use the scalar method. And this question is of course only two-dimensional, or is it 2D dimension. When we're talking about the resultant force, resultant moment in 2D, we're talking about sigma fx first, sigma fy, and then sigma moment, of course in this case about point O. Let's start from resultant force first. Let's say if we start, I forgot, in this question it already gives you the free body diagram. So in a way it means that you don't have to draw a new free body diagram because it is given. So before we start, since we are talking about sigma fx, sigma fy, then we should assign what is the direction of x and y. In this case I will say x is horizontal and y is vertical. So once we set this up, let's talk about sigma fx first. I will write down here sigma fx then is summation of forces or forces that is on the x direction, in this case the horizontal. The first one we look at in this case is 20 Newton. 20 Newton, but in this case it's not in the x. We take the x component 45 degree, therefore is cosine 45 degree. So today we will solve a resultant force, resultant moment on 2D question. In this question it asks you to solve for resultant force and resultant moment about point O. Since it doesn't ask us to solve it with particular method in mind, so we're going to choose the scalar method. Now before we solve any question about force and moment, we will talk about free body diagram. But in this case, since the question already gives you something that is the free body diagram, so in this case we do not really have to redraw it. So that will be the free body diagram. Next, before we start calculating, then we should decide on which one is x and which one is y. In this case I will say x is to the right hand side positive and y upward positive. So now since we actually set up the axes, then we could talk about sigma fx. Let's say on the right hand side, as we say before, positive. There are two forces that we should contend with, the 20 Newton and the 10 Newton. The 20 Newton downward and to the right, therefore positive. In the x direction, it has a component of 45 degree, so cosine 45. Whereas the 10 upwards and to the right, again this is x, so we only consider the right hand side, since it's right, then therefore positive. It has a component of 60 to the y direction, opposite this way, therefore it has the component of sine 60 degree. If we combine the two together, then we have, then is equal to 22.8. Since both 20 and 10 carry the unit of Newton, therefore that 22.8 is 22.8 Newton. Positive therefore to the right hand side. I will summarize it up here for now. Sigma fx is equal to 22.8 Newton to the right hand side. Now it's time for us to do sigma fy. Now we're going to do sigma fy, the summation of force in the y direction. So we start the equation the same way, sigma fy, then we say upward positive. In this case we have two forces still that have in the y direction. First is the 20 Newton is downwards, therefore this time it becomes minus 20. In the y direction, it's opposite the angle, so it becomes sine 45 degree. Then we also have the 10. The 10 Newton going upwards, therefore is positive. Plus 10, in this case, cosine 60 degree. If you calculate them both, then we have the summation of minus 9.14 Newton. What does it mean is that it is negative. Therefore, we assume upwards. Once you get negative, it's the opposite direction to what you assume. Therefore, it's 9.14 Newton downwards. Now it's time for us to actually consider the moment about point O. Now it's time for us to calculate the summation of force in the y direction. We start the equation the same way. Sigma Fy. In this case, we say upward positive. So just to make sure that we understand the same thing, we have a symbol here. The first force we're looking at is the 20 Newton. Since this time the component in y is downwards, therefore it's minus 20. Component in the y direction is sine 45 degree. The next one is a 10. The 10 is upwards, therefore it's positive. So plus 10, in this case, cosine 60 degree. Combine the two, you have minus 9.14, which actually means, in this case, Newton, the unit is also Newton. Negative, because we assume that the force upward is positive. Therefore, this summation becomes downwards, negative. Now, I put it up here because we need somewhere in the middle to calculate something else. Therefore, I put sigma Fy is equal to 9.14 Newton downwards for now. However, these two forces is not really resultant force as such, because this is only summation in x, this is only summation in y. The answer we want is one force of the total resultant force. The picture, in fact, if we draw, we have sigma Fx going to the right here, which is 22.8 Newton, right? Then we also have sigma Fy downwards here of 9, so a little bit smaller, so 9.14 Newton. Therefore, the real resultant force is here, like so. Normal summation of vectors there. This is our what we call sigma F, which is the total resultant force. Then this one here is from the triangle Pythagoras. Sigma sigma F summation, the total resultant force, therefore is 22.8 square plus 9.14 square over all inside the square root. This one here calculate run out equal to 24.6. In this case, the unit is still Newton and direction is that way. However, direction like this that do not actually is not specific enough. Therefore, what we have to do is we will assign the angle here. In this case, you can use either angle to the y direction or to the x direction. More popular, they use x direction. So I will follow. Let's call that angle theta. That theta is from the tangent of that line of that side, 9.14, and that side over that side. Therefore, theta is equal to arctangent of 9.14, that side, over 22.8, that side. That one run out equal to about 21.8 degree. Now we become more specific then. In this case, x direction is here, and that one 22.8 degree. So this is our real answer. The resultant force is equal to 24.6 Newton with the angle to the x direction of 21.8 degree. So now since we have done the total force, then it's time to move on to resultant moment about point O. Let's calculate moment about point O. We start the equation the same way. State first what we are calculating. In this case, the summation of moment of point O, then we assign the positive direction we want. In this case, we'll say anti-clockwise positive. Now, let's talk about these two forces one by one. In this case, what I will do is I will take forces components of force and then time the 90-degree distance. For example, for the 20 Newton, one component will be in the y direction, 20 sine 45 degree, and the other one is in the x direction, which is 20 cosine 45. Let's put it in for now. So I will have again to the upright 20 sine 45. I haven't put in the symbol here, 45 degree. Now, if I take the component in the 20 in the side, which means that way, meaning I'm talking about this force here. This force here have a distance, 90-degree distance. Since the force is vertical, 90-degree distance is horizontal. Therefore, from here to here is 60 degree. Then we put in the 60, not 60 degrees, sorry, 60 centimeter. My apologies. Then, because the one is pushing downwards, about point O is rotated clockwise, which is opposite to what we say positive. Therefore, that one is a negative one. The next component is 20 cosine 45 degrees. The 45 degree, therefore, it is this one here. From here, taking cosine 45 is into the angle. It is a vertical, it's horizontal one. Since the force is horizontal, the 90 degree then therefore is vertical. But since this one here is in the same level with point O, there is no distance, which means that distance is 0. That one could be plus or minus the same. I will put plus. Then the 10 Newton, again we have two components. One is in the y direction, one is in the x direction. Let's talk about the y direction first to be consistent with last time. Then it's 10 cosine 60 degree. That 10 cosine 60 degree from here into the y direction is this one. Now, since the force is vertical, the 90-degree distance is horizontal, but it goes through point O, therefore there is no distance. In fact, it's become 0. Then plus or minus is the same. Then the next one is the 10 sine 60 degree. The 10 sine 60 degree is this one here. From here into this one, into the x, or in this case horizontal line, that one. Therefore, the 90-degree distance is vertical. In this case, it's 40 centimeter. Therefore, the moment is time 40 centimeter. Now, this one here is pushing to the right. About point O is go anti-clockwise. Therefore, it is a positive sign there. If we summarize all this, we have minus 502. This is numerical. In the physical sense, it means 502. Notice that all the force here is newtons. All the distance here is centimeter. So you time them, then it's become Newton centimeter. Right? Since it's negative, we assume that moment will be, the summation of the moment will be anti-clockwise. Negative, then it go against it, meaning it is going clockwise. Right? Therefore, we also have the summation of moment about point O, or resultant moment about point O, is equal to 502 Newton centimeter clockwise. Now, this is the answer. This, in fact, all calculation, this is the only two set of answer. But this is numerical. What, again, as an engineer, we will interpret it into wording, which I will put it here. We will summarize in the wording. Then we have resultant force of 24.6 Newton right and down. circuit and angles of 21.8 degree to x-axis. That will be one of the answers. Again, this is resultant force, and of course, since the question asks for two answers, resultant force and resultant moment, we also have resultant moment of 502 Newton centimeter clockwise. Do we have enough space? Clockwise. And this is done. Thank you for your attention. I will see you again in the next example. Thank you.